Hi, Assalamualaikum. Our group name is The Boys. We have two members, Muhammad Aris bin Hasmadi and Adwa Syafi bin Syahril Nuruddin Kuswadi. Yeah.
We are really grateful because we managed to complete this video presentation within the time given by our lecturer, that is Dr. Azhar Ahmad. This assignment is impossible to be done without the amazing cooperation and effort of our group members, Adwa and Haris. We also sincerely thank our lecturer of calculus, that is Dr. Azhar Ahmad, for the guidance and willingness to help us in what we are lacking when completing this assignment, and surely for teaching us this course. Last but not least, we would like to express our gratitude to our family members who keep on encouraging us all this time. So, our group has chosen the topic related rate, that is also known as rate of change, for this assignment topic, that is application of differentiation.
Introduction. One of the application of differentiation in the fundamental theorem of calculus is related rate, which is rate of change. Related rate normally involving figure out a rate of changing of a quantity from another quantity that is given sufficient information. The related rate is known for its benefits in the application in life. An example of application in real life regarding related rate is we can figure out the speed of two vehicles that drive in different direction if each of the vehicle speeds in direction is known. On to the next slides. Problem statement. A 20 feet long pole against a concrete wall on a flat ground. The bottom is initially 7 feet long away from the concrete wall. The long pole is moving up when it is being pushed towards the concrete wall at the rate of 1 over 5 feet. Calculate how fast the top of the pole moving up the wall 10 seconds after we start pushing.
The objective is to determine the rate of the top ladder moving up after pushing it, and to apply Pythagoras theorem formula in differentiation.
So, here is the image of situation. We can see 20 feet pole rests on wall. At first, the bottom of the pole. Let's say the bottom we call is X and the top of the pole is Y. X is given 7 feet away from the wall. However, when we push it towards the wall at the rate of 1 over feet per second, the value of X is decreasing. And we wanted to find the rate of the top of pole or Y moving up after 10 seconds.
For the first step, we can draw an appropriate diagram and label quantities that has given related to the problem, so we can understand it better. From the problem statement, we know that the bottom of the pole is 7 feet away from the concrete wall. We also know that the pole is moving up at the rate of 1 over 5 feet per second. Based on the question, it asks how fast the top of the pole is moving up, which is dy dt. So, from the information given, we know that the SDT is 1 over 5 feet per second, And the question asks us to find dy dt.
From the diagram that we have shown, we know that this question is related to the Pythagoras theorem. As we all know, the equation for Pythagoras theorem is x squared plus b squared equal to c squared. Therefore, we can substitute the information given into an equation and differentiate the equation. Next, we know that the bottom of the pole is 7 feet away from the wall before it being pushed up. So, we want to find the distance after it is pushed. Therefore, we substitute the information of rate and time to find the distance after 10 seconds. After we calculate the distance, we get to know how long the bottom of the pole from the wall after 10 seconds.
Next, since we already know the value of x, which is 5, we can find the value of y. We can use the Pythagoras theorem method once again here. In order to find the value of y, first we must substitute all of the known values into the Pythagoras theorem formula, and we will get the answer y equal to square root 375. The last step is we use the equation that we got from step 2 before, which is 2y times dy over dt plus 2x times dx over dt equal to 0. We must substitute all of the values that we got from step 2 and 3 earlier in order to find dy over dt. So, at the screen, we get dy over dt equal to 0.052 feet per second.
As a conclusion, the rate of the top of the ladder moving up the wall after pushing it is 0.052 feet per second. We can apply the Pythagoras theorem formula when solving any problem that involves finding an unknown side of a triangle.